Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dears, assalamu alaikum wa rahmatullahi wa barakatuh. Hope you will be fine and enjoying the life. Dears, today we will discuss the properties of correlation coefficient in this video. So you should watch this video with full concentration, and a request with you, if you didn't subscribe our channel until now, so please subscribe to my channel for more lectures and more information about statistics. We will discuss one property step by step of the coefficient of correlation. So the first property of the coefficient of correlation is that it is a pure number, that is, it has no unit. What is mean by this pure number? It means that it is not in any unit, that is kilogram, liters, milligram, and any unit we are using in the real life for some things. So it is not in the units, it should be a pure number, that is 1 minus 1 plus 1, 0.23 and so on. Okay, so it is the first property of the correlation coefficient. The second property is the correlation coefficient, that is rho or R. We are using rho for the population and R for the sample data. Its range is from -1 to +1, that is -1 is less than or equal to R is less than or equal to +1. Okay, this is the range and second property of the correlation coefficient. The third property is the correlation coefficient between two variables is known as simple correlation or correlation of zero order. If we find correlation coefficient between the two variables, just two variables, so it is known as simple correlation or correlation of zero order. Okay, the fourth one is it is not affected by coding, linear transformation of variables or variety values. If you transform the values of the variables x and y, so it will not be affected by this transformation. Okay, this is the fourth one property of the properties of correlation coefficient. The fifth one is the relation between the correlation coefficient, that is R, and the regression coefficient beta xy and beta yx is R is equal to under the square root beta xy multiplied with beta yx. So the relation of the R correlation coefficient with the coefficient of regression, that is beta x and beta y, is that correlation coefficient is the geometric mean of the regression coefficients of beta xy and beta yx. Okay, the sixth one is the sign of R, that is correlation coefficient, or rho, will be the same as that of beta yx and beta xy. If you have the plus signs or positive signs of beta xy and beta yx, then the sign of the R or rho, that is correlation coefficient, will also be positive. If these are negative, then this will also be negative. Okay, here's the seventh property of the correlation coefficient is if the two variables are independent, the correlation coefficient between them is 0, but the converse is not true. If the two variables x and y are independent, then the coefficient of correlation will be 0, but the converse is not true. What is mean by this? It's mean that if the correlation coefficient becomes 0, it doesn't mean that these variables must be independent. It may be dependent but not linearly. Okay, if the correlation coefficient, you find out the first the correlation coefficient and it becomes 0, so it doesn't mean that the variables x and y are not dependent. It may be dependent but not linearly. Okay, the property number 8 is if rho or r is equal to 0, it shows that the relationship between the variable x and y is not linear. As I said in the 7th property, if the correlation coefficient becomes 0, it doesn't mean that the variables are independent. It may be dependent but not linearly. So in this property number 8, they say that if it becomes 0, so the relationship between x and y is not linear. It may be, there may be dependency but not linearly. Okay, the 9th property of the coefficient of correlation is the relationship between the correlation coefficient with a regression coefficient is beta y x is equal to rho sigma y by sigma x, and beta xy is equal to rho sigma x by sigma y. If you find out the correlation coefficient of y and x, then in the numerator you should take the standard deviation of y. If you find the coefficient of correlation of x and y, then the standard deviation of x will be in the numerator. Okay, so if you have the three values beta y x, rho, standard deviation of x, then you can find out the sigma y or standard deviation of y. In this situation also, if you have the three values, then the fourth one you can find from this equation. Okay, 10th number property of correlation coefficient is that arithmetic mean of two regression coefficients is always greater than the positive correlation coefficient between the variables. What is mean by this? The arithmetic mean of two regression coefficient. If we have beta xy and beta yx, these are two regression coefficients, and you find the arithmetic mean of these two, this will be greater than the positive correlation coefficient. Okay, now we are proving this symbolically. Rho sigma y by sigma x, it is equal to beta yx, rho sigma y by sigma x, plus rho sigma x by sigma y, which is equal to beta xy, sigma rho sigma x by sigma y, and it will be multiplied with 1 over 2, which is the arithmetic mean of this. Okay, beta yx and beta xy arithmetic mean is this one. It will be greater than or equal to rho, as we said in this positive correlation coefficient, greater than the positive correlation coefficient. So we take greater than or equal because it may be equal, but mostly it should be greater than rho. So if you multiply 2 on both sides, sigma y and sigma x on both sides, and divide rho on both sides. Okay, so if you multiply 2 sigma x sigma y, then this 2 will be cancel out, and this 1 2 will be on this side, on the right hand side. Okay, and if you multiply sigma x and sigma y, so the denominator sigma x and sigma y will be cancelled out, and you will get sigma square y plus sigma square x, which is sigma y will be multiplied with this, so it will become sigma y square, and sigma x will be multiplied with this, and it will become sigma x square. And also sigma x and sigma y will be on the right hand side because we multiplied on both sides. So if you now shift this term and right hand side to the left hand side, so here will be 0 you will get on the right hand side, and it will become sigma y minus sigma x whole square. As we know that sigma y square plus sigma x square minus 2 sigma x sigma y, it will become, and which is equal to a square plus b square minus 2ab. So it, by this formula, we know that it will become a minus b whole square, which is equal to sigma y minus sigma x whole square. So it should be greater than 0 because it may be any constant, any value that should be greater than 0. So we use the greater than or equal symbol, but it may be greater than in most cases. This confirms the property. Okay. Here's the 11th property of the coefficient of correlation is r square, the square of correlation coefficient, referred to as coefficient of determination. If you take a square on the correlation coefficient, it will be coefficient of determination, and if you subtract from 1 that coefficient of determination, it will be called coefficient of non-determination. Okay. In the 12th number property, if in a coefficient of non-determination is taken in the under square root, it is referred to coefficient of alienation. Okay dears, so these 12 properties of the coefficient of correlation you may understood from my weak English. So I will hope you will must like and share my video. Inshallah we will meet in the next video. Assalamu alaikum wa rahmatullahi wa barakatuh.